A very good evening, all of you guys. Welcome to Unacademy. Welcome to Creatrix channel. Welcome to the course of Network Analysis Crash Course from the Brahmastra batch. So, I hope you people attended yesterday's class, and we have done very good number of problems and very good different models in the yesterday class. So, let's continue today also. Today, I'll continue with the problems on this basics, and इसके बाद मैं network theorems पे शुरू करेगा आज. ठीक है? चलो, let's start. Are you ready? Am I audible? Everything is fine. So shall we start? Energy दे दो बताओ. Very good evening, Nageshwar. Is it fine? Is everything fine? Am I audible, visible? Everything is fine. Please tell me so that we can start the session. Chalo. So the new batch is going to start on an academy today. That is the Udan batch. Network analysis is going to start today at 7 p.m. अब 2024 का preparation शुरू करना चाहिए तो you can take the subscription from an academy and also you can use the code Shankar for the maximum discount and the best possible guidance. You can use the code Shankar10. Right, thank you. So this is a batches going to start. ये batches में आपको क्या फायदा मिलते हैं ये आप लोग देख सकते हैं. पूरा complete syllabus in a comprehensive way it will be covered. आपका doubts भी clear हो पाएगा. And doubt solving के लिए exclusive sessions and exclusive doubt solving educators मिलेगा आपको and complete material मिलेगा PDF में. ठीक है. आप iconic ले लिया तो आपको printed भी मिलेगा. ठीक है. So these are the batches going to start for 24 and 25 aspirants and आज आपको सब्सक्रिप्शन पे कुछ डिस्काउंट भी है. आप 30% तक सेव भी कर सकते हैं मेरा कोड यूज करके ज्वाइन किया तो Shankar10 and you will be getting this is the final price you will be getting for 1 year 18 and 24 months for plus and iconic subscriptions guys. This today is the last day for it. So for आप IRMs का प्रिपरेशन करना चाहिए तो an academy brought you an initiative for the people who want to prepare for IRMS. So हमारे पास जो गेट है ना गेट सब्सक्रिप्शन और यूपीएससी सब्सक्रिप्शन दोनों मिलके आपको प्रीलिम्स और मेंस के लिए हेल्प करने के लिए दिस पर्टिकुलर इनिशिएटिव केम इनटू पिक्चर. इसमें भी बैच स्टार्ट हुआ दिसंबर 18 से. सो इसके बैच के बाद व्हाट वी कॉल डिटेल्स एक्सेट्रा आपको चाहिए तो आई विल बी शेयरिंग इट एट द एंड ऑफ द क्लास. नाउ कल क्लास में हम अच्छी तरह से थ्योरी डिस्कस करके ज्यादा नंबर ऑफ प्रॉब्लम्स भी किया. सो आज क्या करना. सो मे बी हाफ एन आवर आई विल कंटिन्यू विद द प्रॉब्लम्स ऑफ द बेसिक्स व्हिच आई लेफ्ट yesterday. Okay, I gave some questions as homework for you yesterday. So those questions let me complete it. Then इसके बाद we will start with the network theorems. So आपके लिए theorems का notes भी तैयार करके रखा मैंने. So network theorems, all the principles, everything is ready for you. Okay, so we'll start this. Chalo, let's start with these questions. So ये वाला क्वेश्चन तो आसान है ना ये आप लोग सॉल्व कर सकते हैं. So let's start with this question. So find the currents I and I1. Find the currents I and I1. So please give a try. Uh, ठीक है टाइम. सो रेगुलरली आप लोग इसको सुपर नोड एनालिसिस कर यूज करके सॉल्व कर सकते हैं बट मैंने इस क्वेश्चन को डिफरेंट वे पे सॉल्व करके दिखाता हूँ. आप लोगों को मैंने कल बताया हाउ टू अप्लाई द सोर्स ट्रांसफॉर्मेशन अंडर डिफरेंट टेक्निक्स. सो इसके पहले, सो इफ यू नो दिस concept which generally I discuss in the regular class, if you have a voltage source series with a resistance parallel with another resistance, what is the equivalent is V R2 by R1 plus R2 series with R1 R2 by R1 plus R2. Okay. So by using this concept, you can solve this question. You can find the I1, then you can find the I. Everything can be obtained easily. Uh, Suppose you take this node voltage as V1. Okay. Um, Super node analysis कर सकते हैं हमने V2. Okay. So let's solve the question. I will show you the different tricks to solve the same question. So let me start with the normal basic method. 24264. ठीक है. कल आपको क्लास नहीं है. Again, we continue on Monday. Next Monday to Friday, we have classes. Friday, syllabus will be completed. As I told, this is the plan we have, right? To this week, 2 classes. Next week, 5 classes. In 7 classes, entire syllabus will be finished up. So, tomorrow, no class. And next Monday to Friday, we will be having the classes. Okay. So, this we have already discussed. So, as usual. Now, let's start the problem. ये मेरा नोड वोल्टेज V1, V2, एग्जामिनर को ये चाहिए I1 एंड I. इसको निकल सकते पहले V1 minus 24/2, V1/6. Don't touch the super node. तो ये तो super node. Yes or no? So when super node comes, what we need to do is, what is super node, sir? When there is an ideal voltage source between two nodes and there is no resistance, because the ideal voltage source current can be any value, we cannot write the equations directly. So instead of writing this current, what I will do is, this current is equal to sum of these two currents. So I write these two currents. So what are they? V2 by 8 and 3 is leaving, equal to 0. So take the LCM. 4V1 minus 48, 96. Okay, just a minute. इतना ज़्यादा क्यों आ रहा है? Okay, V1 12, LCM is 24. We'll use this letter. Similarly, inside the super node, if you apply the KVL in the loop, what is the KVL? V1 plus 4 minus V2 equal to 0. So V1 minus V2 equal to minus 4. Equation 2. This is equation 1. Solve 1 and 2. What do you get? You can do this. If you have already done, please comment. V1 V2 कैलकुलेट किया तो बताओ, नहीं तो मैं कैलकुलेटर में अप्लाई करके चेक करके बताना चाहिए. V1 is equal to 4, V2 equal to, let me do the calculation. So you get V1 equal to 12, V2 equal to 8. Okay. Now what is the current I? It is 24 minus V1 by 2. 24 minus 12 by 2. That will give you 6. What is I1? It is total current is I na minus V1 by 6, because this current is equal to this minus this, are sum of these two. It is your convenience. So I minus V by 6 now, V1 by 6 now. I is how much? 6 minus 12 by 6. 6 minus 2, 4 is the answer. So 6 and 4 are the answers. So option A. Okay. I and I1. So this is one method to solve this question. Maybe थोड़ा सा ज़्यादा difficult तो नहीं है, यहीं पे एक दो steps extra ले लिया. But now how to do the question in another different way? Let us see. चलो. Let me solve the same question by different technique. Now apply source transformation. This part, इस वाला part में source transformation आपने apply किया तो it will be 8. What is 8 3s 24. Here also it is 2 parallel with 6. That will give me 12 by 8. 12 by 8 will be 6 by 2, 3 by 2, 1.5. And this will be 24 into 6 by 8. That is 18. So this is the circuit, and in between you have a voltage source of 4. You need I1, and this is some V1. Okay, whatever it might be. So this is V1 by 6. Why I am writing that? I have a reason for it. Because this branch is disturbed, I will be disturbed, but I1 will remain same. What is I1, sir? What is I1, sir? Here 18 plus 4 plus 24 by total resistance 9.5. That will give me 22 plus 22, 24, 46 by 9. Sure, just a minute. गलत क्यों आ रहा है? क्या हुआ? There's no chance of getting a mistake. Any mistake I have connected, done any calculation mistake in this equivalent, because it should give 100% same answer. 8 3 to 24, negative positive 4, perfectly correct. I1 branch is not disturbed. So I1 equal to this voltage minus the remaining voltages by 9.5. Okay, it is okay 36 now. No, 20, 28 plus 8, 36 plus 146 only. I have done any calculation mistake. Anybody identified? Please tell me here, because the process 100% correct. Anybody here? I will share at a time here both of them together. First, tell me, we have done any calculation error in this part? कंपलसरी इस पे आंसर तो आना ही चाहिए यार, कोई डाउट ही नहीं इस पे. 38 होना चाहिए. एक मिनट, इसका पोलैरिटी देखो, प्लस एंड माइनस ना. ओके, मैं गलत ले लिया. दिस इज द मिस्टेक. इक्वेशन तो सही है, ठीक है. आई थिंक केवीएल V1 इट इज प्लस माइनस ना. V1 minus V2 equal to plus 4. Now it is correct now. It is plus 4 actually. So here also the polarity must be reversed. So that's why if one method, if you have done, if it is correct, it must be correct in every method. Now what do you get here? Perfect. Okay. 18 minus 4 plus 24. So 14 plus 4, 38 by 9.5. Perfectly correct answer. Okay. It is 4 amperes. Now, if you need I, what is I, sir? I is equal to, here I disturbed, don't take this figure. I is equal to V1 by 6 plus I1, V1 by 6 plus I1. What is V1, sir? What is V1, sir? What is V1? V1 is this voltage, sir. V1 is this voltage, sir. This voltage is equal to, already I got I1 equal to 4 ampere. 4. So this will be 32, sir. So 32 and 4, 32 plus 4 kitna? 32, 36. 36 minus 24, 12. So V1 by 6 is 12 by 6 plus I1, that is 2 plus 4. What is the answer? 6. Same answer Ayana, but maybe relatively less number of calculations we have done. So the same question try always by multiple ways. Instead of doing the regular method, I have done by source transformation. मेरे को same answer आया दोनों केस. ठीक है, चलो let's go for the next. Thank you, Pankaj. Chalo. Next question. So consider the network shown in the figure. चलो next. So consider the network shown in the figure. Find the current I. Okay, the current IL is given by I is given. I think IL we need to find. This is already done here. For the circuit shown in the figure, the value of the current IX. See, this is the ammeter. You need to find the current IX. This is not at all a difficult question. 10 seconds भी ज़्यादा है इस question को. So 10 सेकंड भी नहीं देता हूँ मैंने. ओके 10 सेकंड ले लो. ट्राई करो यार इतना टाइम तो ठीक है. यस यस यस. यस्टरडे कुछ नहीं मेरे को याद है. मेरा दिमाग भी काम कर रहा है. ठीक है हो गया टाइम. कितना आंसर आया? अरे सर आंसर नहीं दिया अभी तक. क्या हुआ? चलो आइडियल एमीटर का मतलब शॉर्ट सर्क्यूट एज्यूम करो. शॉर्ट सर्क्यूट एज्यूम किया तो 2 पैरेलल विथ 2 तो 1 होता है सर. 1 प्लस 1 तो 2 होता है सर. सो मेरा करंट कितना होता है सर? मेरा करंट तो 12/2 दैट इज 6 एम्पियर. 6 यहीं पे आएंगे तो 3 और 3 हो गया क्वेश्चन. ठीक है. समटाइम्स दिस काइंड ऑफ क्वेश्चंस कैन अपीयर इन योर एग्जाम व्हिच कैन इजीली गिव यू मार्क्स. ठीक है. चलो. So the next question, find the average value of the current waveform shown in the figure. A current waveform shown in the figure, average and RMS values generally I will discuss in the AC analysis, but okay. यहीं पे आया basics में भी we can do it. So please give a try this question and try to give your answer. इसका average value कितना? Give it. Give a try. Option A. ठीक है. चलो. Let's see how to do this. Our time to high. Meanwhile, I will do 10 seconds, 5 seconds, 4 seconds. The average value, uh, no, 2.5 was not correct answer. See, take the middle point here. Okay, you assume, okay, take the midpoint of these two. For RMS, we need to worry more, but average value is always easy. So, if you have x equal to x1 plus x2, what is the average value of x? This can be given as x1 average plus x2 average. Now, what is x1 average? Here, it is a combination of a DC input of 7.5 and also a AC triangular waveform like this, whose magnitude is equal to how much? 5. Okay, this is your x1, x2. What is the average value of this triangular waveform? Is 0. Positive half, negative half cancels. So if you add these two signals, you get this signal. Okay, so maybe you may also take like this this 10 signal and negative this 5 to this one. This negative wala signal भी add किया तो ये आएगा. In that way also you find the average value, you get the same answer. But in that case average के लिए area over one time period by time period वाला पूरा formula apply करके करना चाहिए. But ऐसा ले लिया तो क्या आसान क्या क्यों होता है? पॉजिटिव नेगेटिव हाफ कैंसिल हो रहा है. सो x1 का एवरेज तो पता है DC, इट इज 7.5. x2 का एवरेज विल बी 0. मेरा आउटपुट विल बी 7.5. सिंगल स्टेप पे आपको आंसर मिलेगा भाई. ठीक है. सिंगल स्टेप. वेरी गुड वेरी गुड. हु आर दे? साहू and Mohammed, both of you, right answers. Option C is the right answer. So let's move for the next question. Again, it is of the similar model. The current waveform shown in the figure is applied to an inductance of 2 Henry. The voltage across the inductor at 1 second. So let's take the similar amount of time, not that much. Okay, 50 सेकंड ले लो, ट्राई कर लो. So the current waveform थोड़ा सा आगे गया, don't worry, ऊपर गया ना. The current waveform, ये वाला current waveform है, ये current इंडक्टर पे गया 2 हेनरी वाला इंडक्टर में. वोल्टेज अक्रॉस द इंडक्टर चाहिए आपको 1 सेकंड पे. टाइम अप. चलो. Here, what is this signal? It is a ramp signal of, what is the slope of this signal? y2 minus y1 by x2 minus x1 is 5. This signal is 5t. Okay, ये वाला signal तो 5t है. So what is the voltage across the inductor formula, sir? L dIL by dt. ठीक है. So don't directly substitute the value of I here, sir. I तो 1 second पे 5 होता है, sir. So directly 5 d by dt of 5 is 0, sir. So my answer is 0, sir. नहीं sir, 0 options में भी नहीं दिया. And don't apply the value directly, guys. At any instant of time, if you need a current value, even it is a variable quantity, at one instant it is always constant. So don't take d by dt of the value and take the answer as 0. That is absolutely wrong. So क्या करना चाहिए sir here? First write the equation. So L कितना 2 d by dt of 5t. So that will give me 10. Right? So this is the value. Now if you substitute, it is independent of time anyway. What is the VL at 1 second? It is equal to 10. ठीक है. VL, so it is the VL value from, okay, this is from 0 to 1. 0 to 1. 1 to, I mean 2 to 4. 0 to 2, this is the equation. 2 to 4, maybe it changes, that doesn't matter because we are not worried about that. Okay, so can be equal to 1 second. What is the value you are getting is 10 volts plus 10. Yes, right. Chalo, next. Very good. 10 volts, 10 volts. Mohammed, Yashu, Shubham, Paramesh, 3TSH. इसका मतलब क्या? 3 Shubham. Okay, good. Correct. चलो next question पे. सो एग्जामिनर तो दिया ये वाला करंट है और ये वाला वोल्टेज, आप ये निकालना चाहिए वोल्टेज Vs. सो प्लीज ट्राई दिस. ये भी मैं कल होमवर्क दिया. Okay. So given that I1 equal to 1 ampere, V2 equal to 2. So 2 by 1 कितना current चलेगा 2 amp. Already this is given as 1 ampere. According to KCL, this must be 1 ampere to satisfy KCL. Okay, exam में को क्या चाहिए? BS चाहिए. Because I don't know this R, I cannot find its drop. But I can find its drop 1 volt. I can find its drop 4 volt. So take the loop equation. BS equal to, what is that? Minus 1, minus 4, minus 2, minus 7. Right. Chalo, next question. So here it is not a transient question, guys. Okay, it is normal networks question only. So give a try for this question. For the circuit shown in the figure, time constant, different time constants are present. What are for charging and discharging? Time constant is given by R equivalent into C equivalent. So this is charging, this is discharging. Charging में time constant कितना, discharging पे time constant कितना is, that is the question given. Try this question. ज़्यादा time तो नहीं चाहिए इस question को. Come on, 5 seconds more. 4, 3, 2, 1. It's done. So this is the charging cycle and this is the discharging pattern. You are not asked about the formulas and all. Here what you need to find is just what is the charging time constant. 1K into zero point 0.5 into 10 power minus 6. So 0.5 milliseconds. That is, what are the charging? Charging to 1. ठीक है, charging is 1, so option BD eliminate. What is the discharging time? Discharging time तो क्या? In this way. Now listen carefully. When source is switch is connected here, this is the part. Here you are finding the discharging time constant. Now these two resistors, these two capacitors are connected in series because the switch is here, so it is not connected to this. Only this part is there. Same current will flow in these two elements. So these two are in series. So what is the C equivalent here is, when capacitors are in series, overall will be C1 C2 by C1 plus C2 because they are equal 0.5 by 2, 0.25 microfarad. So discharging time constant is R equivalent into 0.25 microfarad. So 0.25 milliseconds. 0.25 milliseconds. So that is your TD. Right. Next. ये तो आसान क्वेश्चन है, छोड़ो. Let's try this question. The voltage across the 10 ohm resistor shown in the figure, the average power dissipated by the resistor. Firstly, I'll tell you what is the average power formula. V average is equal to VRMS whole square by R. Okay, please try now. Thank you, Ramesh. Thank you very much. All the best. So give a try. Please try. So here, uh, if you have a signal x1, if you have a signal x2, what is x1 square? What is x2 square? It is same or not? Because if you square this signal, negative will come to positive, it will be same. What is RMS? RMS is 1 by t integral 0 to t x square of t dt. So RMS is calculated for x square na. So if x1 x2 are not same but x1 square equal to x2 square, for example, okay, then x1 RMS is equal to x2 RMS. By using this concept, what is the RMS of this signal? It is same as DC. Okay, it is same as DC. You can try to find integration, there is nothing wrong, but after squaring, it will give you the same thing. Okay, after squaring positive half and negative half whole square. Average value is a different concept, then area wise we calculate this part will come, but here RMS value is required for average power. So, what is the average power dissipated? VRMS whole square by R resistor value कितना दिया 10. So what is the answer? 10 watt. Option B. Very good, Shubham. Right answer. Chalo, that is about this question. Let's move further. Little fast we are moving. Okay, so that because we need to do more number of questions in the available amount of time. And also I plan to start network theorems today. See, actually, I thought of taking only 1 hour a day, but due to some reasons, tomorrow and day after tomorrow, I'm not able to take the classes. That's why yesterday I took 2 hours almost. Today also, I'm taking 2 hours to cover that. Such that next week, compulsory, under any case, I need to finish the syllabus for you people so that you get sufficient time for revision of other subjects also. So, please try this part. So, again, we will be meeting on next Monday, same time, 4 to 6. Okay. ये कॉम्प्रहेंसिव नहीं भाई, ये तो क्रैश कोर्स, फास्ट वन, फास्ट एंड फ्यूरियस जैसा, ठीक है, फास्ट ट्रैक कोर्स. This is for already those who know networks from my comprehensive courses. मेरा comprehensive courses तो already YouTube पे है. So already if you know comprehensive, you can understand this for revision and practice. ठीक है. So consider the network shown in the figure. The current source shown in the figure. ये current source जो है ना, ये deliver कर रहा है, absorb कर रहा है is the question. So let's try this question. Solve it, guys. 20 seconds more. अगेन शुभम तो दिया ऑप्शन बी, बाकी लोग भी ट्राई करो. Okay, that course is also full. Only concept remains same. Only extra problems will add on that. Chalo. So here, how to know whether it is delivering or absorbing? That concept I can give you. Suppose you have a voltage source. Current is in this direction. Absorb positive to negative. Assume V and I greater than 0. If current is negative to positive, it is delivering. Current is positive to negative absorbing, negative to positive it is delivering. Okay. So listen here. ये तो ओपन सर्किट है, इसमें कोई करंट तो नहीं चलेगा, ठीक है. देन हाउ करंट विल फ्लो थ्रू दिस फेलो and this fellow, and the same current will come here, and the drop will be 2 volts. Drop will be 2 volts. So let us assume this as Vx. It is assumption because source ka polarity can be reverse also, but passive element polarity is always positive to negative, but source polarity can be anything. So what is Vx? By taking the external loop into consideration, what is your Vx by KVL? Vx equal to 2 plus 2 plus 2, that is 6. Means my assumption is correct. So what is the Vx is 6. So you see the current direction, it is going from negative to positive. So it is delivering. How much power is delivered is voltage into current. That will give me 6 watt. Hey, deliver 6 watt कहाँ पे? हाँ, uh, yeah, no doubt deliver 6 watt. आपको भी सेम आया? नहीं है तो इसका पोलैरिटी उल्टा करो, देन यू गेट डिलीवर 2 वाट. ओके, नो डाउट आंसर इज करेक्ट, इट इज डिलीवरिंग 6. ऑप्शंस तो गलत है. Okay, you can also do like this. Power delivered must be equal to power absorbed. Always you want to cross check your answer. Power delivered must be equal to power absorbed. Here this fellow is absorbing the power, na? That fellow delivering. So because the arrow direction. What is the 1 ampere? How much it is delivering? How much it is absorbing? 2 volt source is absorbing 1 into 2. 2 ohms is absorbing 2 into 1. Again 2 ohms is absorbing 2 into 1. Total how much? 6 watt. Power delivered, power absorbed, same. Understand? Yes, yes, yes. So if examiner give this as reverse polarity, in that case maybe you get to 2. Here 100% is 600. Okay. Next question. Yeah, this is the last question in the basics. So then we will be moving for the network theorems. Okay, chalo. So inductance of 2 Henry is connected to the terminals of the device whose voltage and current are in this particular fashion. Okay, and the time constant of the network is, what is the time constant of this network? Suppose you have some network whose VI characteristics are like this. We need to find the time constant. What is the time constant formula? L equivalent by R equivalent. L equivalent is 2, R equivalent निकाल के you should substitute करना चाहिए. चलो. Okay. Right. Please try. Please try. Okay. Here, what is the resistance value is R is equal to V by I. That is, here the slope will give you, inverse slope will give you the resistance. You can also say when the current zero, voltage zero, current value, all those things, but simply R is equal to 10 by 2, 5. So 2 by 5.4. Chalo. That will finish your basics for the crash course. As you have seen, hardly 1.5 lecture I have taken, but you can observe every single concept is covered or not. Source transformation, Telegen's theorem, voltage division, current division, some equivalent circuits, node analysis, super node, every concept covered हो गया. That is how we have discussed the number of questions here. So let's move for what we call the next chapter, that is network theorems. So let's move for the next chapter, that is called network theorems. Chalo, let's discuss. So here, maybe for next half an hour, I will be discussing the theory first. Then we may move for the problems. Okay. So why we use the theorems? Generally in regular class we discuss all these things, but quickly I will finish this part. Whenever you have a complex network with several nodes, meshes, independent sources acting simultaneously, आपके नेटवर्क के अंदर बहुत सारे नोड्स है, meshes है, बहुत सारे एलिमेंट्स है, कॉम्प्लेक्स हो गया आपका नेटवर्क. इसमें if you need the response in one particular branch, इसको response निकालना थोड़ा सा difficult होता है. उस समय पे हम network theorems का help लेके आसान से solve कर सकते हैं. जैसा superposition theorem, Thevenin's where entire network, remaining network might be replaced with one equivalent and this particular branch का response तो आसान से निकल सकते हैं. नहीं है तो इस particular branch का response due to one particular source at a time we find and we add all of them. Like that there are different theorems to do this part. So इसमें first theorem is superposition. So quickly let me complete the theory. 5 minutes. I'll finish the theory, then we will do the problems. Okay, just a moment. Yeah. So the first one, homogeneity principle. 1 minute. So superposition theorem. Superposition theorem का मतलब क्या? In a linear network, first and foremost, very important thing is network must be linear. Network must be linear. नेटवर्क कंपलसरी लीनियर तो होना चाहिए. ओके, नेटवर्क तो कंपलसरी लीनियर होना चाहिए. इन ए लीनियर नेटवर्क विथ मल्टीपल सोर्सेस एक्टिंग साइमल्टेनियसली. नेटवर्क के अंदर मल्टीपल इंडिपेंडेंट सोर्सेस है, बट आपको चाहिए रेस्पॉन्स इन वन पर्टिकुलर ब्रांच. आप यू आर इंटरेस्टेड इन द रेस्पॉन्स ऑफ वन पर्टिकुलर ब्रांच, then we take the help of net what we call superposition. So total response due to all the sources at a time is equal to sum of individual sources by taking on the response due to one source at a time. So while taking one source, how to solve the remaining sources, how to replace the remaining sources means other sources में voltage source है तो we should replace with zero, that is short circuit. Current source है तो we should replace with open. Dependent है तो इसको disturb मत करना चाहिए. These are the things we should apply. But problems point of view when superposition theorem generally don't apply it if it is not required or not asked by the examiner. Why, sir? Because it will take more time to solve the problem for one source at a time and add all of them. Until unless it is not possible, there are some cases like RLC networks with different frequencies. When it is not possible to solve directly, then we may go for superposition compulsory. Otherwise, better to go by normal analysis in the exam and find the response. चलो. So compulsory network तो linear होना चाहिए भाई. इसमें कोई I mean alternative नहीं है. Compulsory it must be a linear network. In a linear network, the total response is equal to sum of individual responses. The linear network में एक और principle compulsory satisfy हो जाएगा. That's one, that is homogeneity principle. Homogeneity principle का मतलब क्या? if any network may, if the excitation, that is the input is multiplied by some constant k, the response in all branches are also multiplied by the same constant k. If excitation is multiplied by a constant k, the response in all branches are also multiplied by the same constant k. For example, take a just a minute here. Okay, fine. Chalo. Now, the J input 36. First case में what happens? 6 parallel with 6, 3 plus 3, 6. So input current is 12 by 6. That is 2. 2 comes here. It divides into 1, 1. कोई दिक्कत नहीं, no problem. Here what happens? 6 parallel with 6, 6. Parallel with 6, 3. 3 plus 3, 6. So the current here will be 36 by 6. 6. So it divides into 3. Okay, sir, no issue here. Up to this, it is fine. Now, this is my I1, I2, I1, I2. Okay, and this is my I. आप ऑब्जर्व कर सकते हैं मेरा इनपुट इज earlier 12 it is multiplied by 3. मेरा excitation multiplied by a constant k, that k here is 3. The response in all branches, earlier it is 2, now it is becoming 2 into 3. Earlier it is 1, now it has become 1 into 3. Earlier it is 1, it is 1 into 3. Excitation multiplied by a constant k, response in all branches are also multiplied by the same constant k. Here the response का मतलब current. ठीक है. Sir, what about voltage? Voltage will also multiply. If it is a resistive drop, voltage will also multiply. If your voltage is a drop across the resistor where V equal to IR, R is a constant. If I multiplies, V also automatically multiplies. So it depends on the where you are taking that voltage. Chalo, that is about your superposition theorem and homogeneity principle. Let's move for the next, what we call the next one. Just a minute. Okay, see here. So the next one, uh, this theorem, what not only this theorem, any network theorem if you take, so these theorems are applicable only for these theorems are applicable only for linear networks. That is network with linear elements like resistors, inductors, capacitors, and the linear dependent sources. Dependent sources makes the network active. So these theorems are applicable for both active and passive also, except reciprocity, which is a special case. बाकी सभी theorems are applicable for any linear network which can be active or passive. So let's see one more theorem here. The next theorem we want to discuss is the Thevenin's and Norton's. Okay, the next theorem we want to discuss Thevenin's and Norton's. देखो, quickly I am revising the things. Directly we will move for the problems. ठीक है? So Thevenin's का मतलब क्या sir? Thevenin's theorem, Norton's theorem, whatever may be the theorem, they are helpful to replace a complex network into a simplified network. So if you have a complex network with several independent sources, nodes, meshes, whatever, must be linear. You can replace any linear network with a simple network of voltage source series with a resistance. That is called Thevenin's voltage. So according to the Thevenin's, any linear network can be replaced by its Thevenin's equivalent of ideal voltage source VTH in series with a resistance RTH. So what is how when you replace the network with its Thevenin's equivalent, original network and the Thevenin's equivalent network, दोनों केस में the same load will take same amount of current. So what is this VTH, sir? How do you find it, sir? VTH is the open circuit voltage measured by making independent sources equal to zero. Sorry, voltage open circuit voltage measured across the terminals. RTH is the resistance measured by making independent sources equal to zero. In regular class, I have already explained the difference between RTH, Rin, R naught, R of the network. All these cases I have explained very clearly during my regular class. Negative resistance, everything I have explained. So if you have that basics you need, you can go through it. But RTH and R are not same every time. So RTH is the resistance measured by making independent sources equal to zero. So while finding the RTH, we are making independent source ka resistance is neglected. Independent source ka internal resistance is different. Resistance offered by the independent source is different. Internal resistance is voltage source को zero, current source का infinity, but resistance offered will be always V by ratio. Okay, let's go. See here. So what I am discussing here, RTH is the resistance measured by making independent source zero. Similarly, you can also replace with its Nortel equivalent of current source parallel with the resistance, where the current source value is nothing but ISC, that is a short circuit measure current measured through the terminals. Okay, so that is about Thevenin's Norton's. Okay, so this is what we call the Thevenin's equivalent, Norton's equivalent. VTH is the resistance measured by making voltage measured open circuit में. ISC is the current measured short circuit. RTH is the resistance measured by making all independent sources equal to zero. So here you observe carefully. So yeah, what is I in this case? It must be same as this and it must be same as this. Then only we can say they are equivalent. VTH by RTH plus RL. But here what is the I? What is I? Current division principle. Total current into opposite resistance by total resistance. So what is the equal? I can say, because the denominators will be same, VTH equal to ISC into RTH, or ISC equal to VTH by RTH. RTH equal to VTH by ISC. Okay, these are the things. These are the relations between various sources. I mean, VTH, ISC, and RTH. Here, one more important point. Exam equations can come from three models. Model 1, Model 1, only independent source, no dependent source. Here VTH you can find, ISC you can find, RTH no problem. Second case, only dependent but not independent. Here VTH, ISC, yes, but RTH can be obtained by VTH by ISC, or V by ratio at source is equal to 0. Last model, okay, wait, wait. Here only independent but no dependent. Here VTH, अरे यार क्या होगा, बैटरी लो बोल रहा है इसलिए deviation. Only dependent but not independent. VTH equal to IS equal to 0, RTH equal to V by ratio. This is not equal to 0. Okay, these are the things, ways you can, these are the three different model of the questions examiner can give you on Thevenin's and Norton's. Okay, just let me change my mic and come. Okay, so that is about your this one. So let's move further. The next one, reciprocity theorem. Okay, so that is about your Thevenin's. Before that, I can, one more thing is very important. Very, 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 very important. That is maximum power transfer theorem. Maximum power transfer theorem. Okay, here, when load is variable quantity, it will tell you the condition for getting maximum power. Okay, So I'm not deriving everything and all. For a DC, what is the condition for maximum power transfer? RL must be equal to RS. In AC, condition, 1 minute, you have Vs, ZS, which is RS plus JXS, ZL, which is RL plus JX. Okay. So now, first possibility, when RL is variable, 1 minute, I will make it table. So what is the variable? RL is the variable. What is the condition for maximum power transfer is RL must be equal to RS square. When RL is a variable quantity, what is the value of RL you should keep for getting maximum power is the condition. Next, XL is variable. What is the condition? XS plus XL must be equal to 0. Both variables. Then you can simply say ZL is equal to complex conjugate of ZS. Load must be complex conjugate of ZS. Here, if XL 0, it is root of RS square plus XS. What is the formula for P is given by here? V square into RL by. This is the generalized formula. XS plus XL whole square. इसमें we substitute the value of RL or value of XL or value of this to get the condition of maximum power at this a particular case. Here, what is the maximum power you get is V square by 4RS. Okay, these are the things we should know for from the maximum power transfer theorem. Then we go for the reciprocity. Reciprocity will tell you this condition. Okay, कोई भी linear passive bilateral network ले लो. What it is giving you is this particular case. Okay, in any linear passive bilateral network, the ratio of response to excitation always remains same even you interchange the input location and output location. So this theorem is applicable only for linear passive bilateral, compulsory passive. Okay, and also we can design some specifically active networks. I will show it in the two-port networks to satisfy the reciprocity, but those are exceptional cases. But by default, it is not applicable for the active networks. Chalo, next. Right. One more thing. So two more theorems are there. Let me explain all of them. Then we can move for the problem. Okay. See here. हम लोग तो इंजीनियर है ना, रिपीट तो करना चाहिए. सो मिलीमैन्स थ्योरम क्या बोलते हैं? आपके पास n नंबर ऑफ सोर्सेस पैरेलली कनेक्ट किया तो जैसा R1, V1, R2, V2 and so on, Rn, Vn. You can replace this with R dash, V dash. What is V dash is given by V1 G1 plus V2 G2 Vn Gn by G1 plus G2 Gn, where G is 1 by conductance, 1 by resistance. So R is equal to 1 by G plus G1 plus G2, G and so on. You can prove this by using what we call इसमें क्या बोलते हैं source transformation से prove भी कर सकते हैं. The next theorem is the duality principle. Duality principle क्या बोल रहा है? According to duality principle, कोई भी network आपके पास है तो it can be replaced by its dual. We can find its response from the dual and again find the dual of the response to get the network's original response. Two times dual will give you the same. So the basic pairs of the dual T is resistor, conductor, okay, inductor, capacitor, voltage source, current source, KCL, KVL, node, mesh, star, delta, Thevenin's, Norton's. Okay. Say for example, very simple. You have a 10-volt source. You have 1, 2 ohm and 2 ohm. What is the current here? 2.5. What is the voltage here? 5. Now apply the dual. Current source of 10. Here, when you replace the resistance with its dual, don't take conductance as 1 by 2. You should take a conductance of 2 mho. Don't think conductance of 2 is 1 by 2. That is equal. Dual may, we should replace the value which is equal to 2. Similarly, if your network may inductor is there, you should replace with a capacitor of same value. Okay. So 2 mho is nothing but 1 by 2 ohms. And this is also 2 mohs. So what is the current here? I by current division principle 5. What is the drop here? 1 by 2 into 5, 5 by 2. You observe earlier whatever the current you got the same voltage here. Earlier whatever the voltage you got the same current. Means if I am not able to find its voltage directly, I'll find its network a current and apply the duality to know the voltage originally. Okay. So in a complex network, when you are not able to find the response directly, you can take the dual of the network. If it is easy for you, you may solve it and apply the dual to the response, you get the original response. Last one and a very important one, compensation theorem. In any network consisting of linear bilateral impedances, independent sources, if a branch having a current I and impedance Z uh, that increases by delta Z. You have a branch with impedance Z, you have increased its value to delta Z, little more. The current and the other branches of the network को disturb हो जाएगा, but इसको same रखने के लिए network is same as the voltage or current produced by if what we call the voltage source of I delta Z placed in the branch replacing the source by their internal resistance. I'll tell you with the help of example which makes your analysis understanding easy here. Okay, so let me explain. Let me take one example. You have 2, 6, 3. Okay. So 6 parallel with 3 is 2, 2 parallel with 2 is 4, 24 by 4 is 6 amperes comes here. And by current division principle, 6 will divide into So total 6 into 6 by 9, 36 by 9. You get 4 ampere here, 2 ampere here. Okay. Now I replace this network with 2, 2, that is 6, 24. Okay. Now what happens? 6 parallel with 2 is how much? So 3 plus I am making it 3. Okay, 3 is added with. This is your I, this is your delta Z. Understand what I am saying? So here 6 parallel with 2 something, whatever maybe. 6 to 8, 8 by 6 to 12, 12 by 8, 12 by 8 is 6 by 4, 3 by 2, 1.5, 2.3.5. So calculator, AB 6 I know. Okay. 6 parallel with 6 is 3, 3 plus 2, 5. 5 means 24 by 5, 4.8. So by current division here, you get 2.4, 2.4. So you observe there is a decrease of the current compared to original by 1.6. Here it is increased by 0.4. Net also decreased by 1.2. So this can be compensated if you add here some source which can increase this by 1.6, decrease this by 0.4, increase this by 1.2. That is given by compensation. So that value is nothing but 263, and here replace the voltage source with a short circuit. Okay, and keep here this I delta Z. What is that I delta Z? I value 4, delta Z is 12. If you keep, what happens? 2 parallel with 6 is how much? 1.5. So 12 by 4.5 will come. What is 12 by 4.5? Calculator. 12 by 4.5. This is, okay, I'm sorry. This is 6 now. We should take this network. 12 by 7.5. 12 by 7.5 calculation will give me 1.6. 1.6 तो 8 पार्ट किया तो 0.2 होता है ना, 3 पार्ट 8 पार्ट, सो 4 पार्ट किया तो 1.2 and 0.4. Current division principle. Okay. So now what I will do is, if you connect here, see, in this network only 12 and 2 and 6 and 4. Sorry, this is also 6. What compensation theorem is saying is, now you connect here the voltage with reverse polarity. What is that? Minus 12. What happens? So you will understand here the current will be, originally if this is, I mean, you know this response, you know this response. So if you connect this, it is 2.4. If you connect this, it is 1.6. But if you connect reverse polarity, so this is 1.6, then what is this? Minus 1.6 now. Okay, so here if you connect, it is plus 12. Okay, but it is minus 12 now. So what is the answer? 2.4. This is minus 1.6. Now it will become plus 1.6. Otherwise, I will explain here itself. If it is minus 12, if it is minus 12, what happens? This will be minus 1.6, and this will be plus 1.6, and this will be minus 1.2 minus 1. Okay, now it is more clear. No? So this will be plus 1.6. And here you get in this direction minus 1 plus 1.2. No? So this direction पे previous 4.8, this direction पे previous is 2.4, this direction पे how much current you are getting? Plus 1.2. How much current you are getting? Minus 0.4, which gives me 2, 4, 6, which are same as my original network currents. So I have compensated the increase in the resistance with this particular source. The value of the resistance and this current, you keep it here such that what happens, it will retain its previous values. This is what we call compensation theorem. I hope now everybody able to understand this. Okay, chalo. Last half an hour of the class. So that is about your compensation theorem. So let's move for the last theorem. This, there is one more thing called substitution theorem must be there. Yeah. Just a moment. Last one. So the last one here. So let me highlight this. Okay. The last theorem is substitution theorem. So substitution theorem तो ये बोल रहा है कोई भी network ले लो, whatever may be the network, there is no restriction. You replace any branch with a different branch. कोई भी branch को different branch से replace कर सकते हैं without disturbing other branch voltages and currents, provided the new branch is accepting same amount of current and voltage same as the previous one. So you can also replace a resistor with a voltage source, current source also, provided the resistor voltage source you have replaced is not delivering, it is only absorbing our current source also. You should take the polarity direction same as the original element direction of the current and voltage. You can also do reverse substitution, that is replacing, you can replace a resistor with a source, source with a resistance also, provided that source is not delivering, it is absorbing. But one thing, if you replace a resistor with a source of its resistance, offering that particular resistance, source resistance is not constant, it will vary with input. Resistor value is always constant. So this analysis is valid for one particular input condition, not every time. So let me show you one example. Let me make the things easy. See, this is the network. 4 parallel with 4, 2, 2 plus 3, 5. Here the current I is 5 by 5, 1 ampere. Okay. Or take 10, 10 by 5, 2 ampere. That will divide into 1 and 1. What is the drop here? 4 volt. So I am saying that according to substitution theorem, this 4 can be replaced with 2 and 2. It can also be replaced with a voltage source of 4 with a current of 1 which is equivalent to a resistance of 4 by 1. Or you can also don't, here there is a difference between source transformation and this. It is not source transformation. Source transformation may arrow direction negative to positive. Here positive to negative because it is absorbing. So you can replace this 4 ohm resistor, connect 4 volt source. Still you get the same answer in the response. But if you change the input, these are not valid. Only this is valid, right? So this is what we call substitution theorem. You can also do half resistance with one current source, whatever you want, you can do. Lastly, one more thing I want to do, explain. रेसिप्रोसिटी के लिए एक एग्जांपल देता हूँ. So 6 parallel with 6 3, 3 plus 3 6, 24 by 6, 4 ampere. Current divides equally to 2 and 2. Now reciprocity theorem तो ये बोल रहा है सेम नेटवर्क ले लो, उल्टा पे कनेक्ट करो 24. Here how much current you get? 3 parallel with 6 2, 2 plus 6 is 8. So here 24 by 8, 3. So what is your I? This is 3. I is equal to 3 into opposite by 2, 18 by 9. This is reciprocity theorem. When you exchange the input and output, you get the same response. But many people don't know how to apply reciprocity if input is a current source. How to apply reciprocity if input is a current source? Many people don't know this. Okay, so let us see that. Because reciprocity theorem, anybody will explain you with respect to if it is a voltage source, how to do it. But if it is a current source, how to solve this? Let me explain. Okay. So same question ले सकते, सेम सर्क्यूट. पाई नेटवर्क ले लिया तो आसान है, बट दिस नेटवर्क की लेना मुश्किल है. Here I apply some current source of 4 ampere. Here I apply some current source of 4 ampere. Okay, and this is my network, right? So here 4 will divide into 2. 2. What is the drop you are getting? 12. So I have given current of 4. I got a voltage of 12. So I better to write this network in a perfect way of 3, 6, 6, 4. Okay. Now what I will do is I will reverse this. How I will reverse? Remove the current source. It is 6, 6, and here you connect the 4 amp. What happens? 4 will divide the current into 2 and 2. What is the drop you get? It is same. Proved? Yes or no? Yes or no? If you apply 4, you got 12. If you apply 4, you should get 5. But you should replace the current source. Removing current source means you should remove open circuits. And when you connect the source, don't connect lightly. You should connect parallel to the load. Okay. Here we should connect it series with the load. Right. So let's start the problems now. 15 minutes बाकी है. ये 15 में जितना भी problems possible है तो उतना कर सकते हैं. ठीक है. So that finishes the theory quickest possible में. Hardly 40 minutes time ले लिया आपका and पूरा network theorems explain किया. So even you revise on your own also इतना time तो लगेगा ना. So network theorems, homogeneity and Thevenin's, Norton's, maximum power, reciprocity, Millimans and duality, compensation and substitution. So let's start the question. First question is ready for you. चलो आप लोग बहुत टाइम से इंतजार कर रहे हैं प्रॉब्लम्स के लिए. शुरू किया मैंने फर्स्ट प्रॉब्लम. सो गिव ए ट्रायल एंड टेल मी द आंसर. हो गया टाइम. व्हाट इज द करंट आई? सर मैं बिना कैलकुलेशन में बोल सकते हैं सर. ये तो +10 है. इसको शॉर्ट सर्क्यूट करो सुपरपोजिशन से. 2 and 1 will be in parallel with the further +10. Same if you short circuit this -10, 2 and 1 will be parallel. So -10 वाला response +10 वाला response तो cancel हो जाएगा because the network remains same in both the cases. So I can say my answer is 0. नहीं है तो आप नोड एनालिसिस कर सकते हैं. ठीक है. So v minus 10 by 2, v plus 10 by 2, v by 1 equal to 0. Okay. Take the LCM. v minus 10 plus v plus 10 plus 2v equal to 0. आपका v कितना होता है? 0. I कितना होता है? 0. सुपरपोजिशन से मैं डायरेक्टली बोल दिया. Or you can do by node analysis, you get the same answer. Option A. Very good, Ashish and Priya. चलो next question. Try this question. एक क्वेश्चन का आंसर बताओ यार. 10 मिनट और है. सो जितना भी क्वेश्चंस पॉसिबल है तो उतना कर सकते हैं अभी. सो थ्योरम्स भी आज कवर हो गया. सो टुमारो, आई मीन टुमारो तो क्लास नहीं, नेक्स्ट मंडे पे नेक्स्ट क्लास है ना, मैं उस समय पे थ्योरम्स और टू पोर्ट नेटवर्क्स कवर करता हूँ. देन ट्रांजिएंट के लिए 2 क्लासेस, एसी एनालिसिस के 2 क्लासेस, खत्म. ठीक है. ओके. Yes, here if you connect two current sources of different values, KCL leaving current is equal to 0, 5 not equal to 0. This is not possible. It is impossible to connect the two current sources of different values in parallel series. So it is impossible. Next question. Violation of KCL. So in the Thevenin's, find the Thevenin's equivalent means find VTH and comment your answer here. VTH कितना? ऑप्शन नहीं दिया, आंसर बताओ। व्हाट इज वीटीएच? ठीक है, सो मेरा को ये चाहिए वोल्टेज वीटीएच, दिस करंट इज जीरो। फर्स्ट थिंग here, when this current is zero, what is this current? Vs by 2. What is this current? 4 Vs. What is this current? 0. So if you apply KVL, because Thevenin's voltage is open circuit voltage measured across the terminal. What is VTH is? Vs by 2 is entering KCL minus 4 Vs plus 0 equal to 0. So आपका Vs कितना होता है सर? 0. Vs 0 है तो ठीक है, तो this current will be 0. This current entire, all these currents are zeros. इसको open circuit करो, then what is that? Vs equal to 0. इसको निकाल दो भाई. So VTH कितना होता है सर? 10. Very good, विश्वनाथन, right answer. ठीक है, चलो नेक्स्ट क्वेश्चन. Here also very important that firstly, what is that? You need this VTH. For finding VTH, we make open circuit this. Across AB, until unless you connect this load, this is open. So it is not possible. It is a violation of KCL because ideal current source cannot be open circuited. If current source may entering current is 5, leaving current is 0, it is impossible. You cannot open circuit the ideal current source. It is a violation of KCL. So try this question. You need to find the reading of the ideal voltmeter. Last 3 seconds. Option B. So here, ideal voltmeter means open circuit always. Current ammeter means short circuit. So you need to find the reading of the VAB. So what is VAB is VA minus VB. That is 10 into R upon R plus R minus 10 into 1.5 by R plus R. R plus 1.5. Because if you open circuit this, these two are in series, these two are in series, I can apply voltage division principle to find this node voltage and this node voltage. You can also do like this. This minus this also will give you VA. Just a loop equation only, nothing great. Okay. I take this as VA, this as VB. Take loop equation. If you take in this direction, by loop equation, V equal to VA minus VB or VB dash minus VA dash. Both will give you same answer. So this R to cancel हो पाएगा 5 minus 15 by 2.5. 15 by 2.5 कितना 6. Minus 1 is the right answer. You can also do from the top. See, 10 into R by R plus 1.5R minus 10 into R by R plus R. Same answer you get. So here 10 by 2.5 minus 10 by 2. 4 minus 5 minus. Any method will give you same answer. Okay, because it is basically KVL only, na? Chalo. Find the Norton's equivalent of the terminals. अभी तो टाइम ज़्यादा तो नहीं है ना, so ये वाला क्वेश्चंस तो कल करते हैं, होमवर्क ले लो. सिंपल वाला क्वेश्चंस अभी करके छोड़ता हूँ मैं. ये एक आसान क्वेश्चन है ना, ये कभी छोटे वाला है, ठीक है. ये डिपेंडेंट सोर्स वाला नेक्स्ट क्लास में, मंडे क्लास में आई विल बी डूइंग इट. Yeah, give it a try. This a single step wala questions. Okay. So if you replace the current source with the open circuit, voltage source with a short circuit, 40 and 10. What is the R equivalent? 40 parallel with 10. 4 by 5. 8. You can also do like this. 40 parallel with 10 is 40 by 1 parallel with 40 by 4. 40 by 1 plus 4. Yesterday class shortcut. Now for ISC, if you make this short circuit, what happens? इस पे कोई करंट नहीं चलेगा. This node voltage is 0 volts. Then 20 minus 0 by 40, 0.5, 0.5. Okay, then this is 2, then this must be 1.5. KCL always. So this must be 1.5. Your ISC will be minus 1. So minus 1.5 and 8 is the answer. Minus is there. Okay. So that's all for today. Yeah, we have done very good number of questions and enough theory भी discuss किया आज. So बहुत सारे questions और है मेरे पास. ये सारे questions तो tomorrow we will be doing it. So आपको notes मिलेगा, थोड़ा सा time लगेगा. Maybe Monday or somewhere I will be sharing the notes of 2 classes together. So you can follow my Telegram channel. This is the Telegram channel का link and this is the Telegram channel name Shankar 10. आप इसमें join करो. You can talk with me. You can have any kind of queries. You can ask me regarding your preparation or regarding the notes, anything. Please join the channel for all the links of my classes and all. So this is about our IRMS initiative by Unacademy. This is our team electrical, that is for your mains preparation of IRMS. Okay, this is for you. So अभी तो offer चल रहा है, so don't miss it. This is the last few hours you have for this particular offer. If you want to save 30% on your subscription, subscribe to Unacademy using my code Shankar10. ठीक है? So if you want to get like exam experience, don't miss this, guys, because this is going to happen this particular Sunday, like January 8th, not every Sunday. So here you will be getting the क्या बोलते हैं, opportunity to crack, write the exam and compete with your fellow competitors so that you can know your original rank and all. आज ही enroll करो यार, वीडियो डिस्क्रिप्शन पे लिंक है, it will ask you the code Shankar10. It is a free mock test where many people throughout the country participate. You can know your preparation levels. So आपको scholarship भी मिलेगा इसमें based on your preparation. आप top 500 में है तो you get 25 to 50%, 100% subscription में scholarship मिलेगा. Thank you very much for your time. See you on next Monday. फिर next class तो next Monday पे, ठीक है? Next Monday to Friday we have the classes. I'll finish the syllabus on that day. Thank you. What is your question, Murali? Sir, Wheatstone Bridge वाला question पे I have already done that model in the regular classes here, comprehensive पे. Okay. When if you need to find the R equivalent, just replace this voltage source with a short circuit. For finding R equivalent, find between these two terminals. Replace this with a short, then these two will be parallel and these two will be parallel. Replace the source by open, replace this by short circuit if it is a voltage source. If you replace this by short circuit, then what happens? This short will come in between these two. Then R parallel, this R 1.5 R will be parallel. That is how you find RTH. Okay. It, you are asking this question only? You are asking for this question? Source को short करो यार. बस. That's all. Whether it is 1.5 R or R, rule is same na. So if this voltage is given, just apply voltage division principle. Find this voltage. Okay. Then based on that, we can find the relative resistances. Not R value you cannot find. If voltage value is given, based on this, you can find relative resistances only. That is resistance ratio, you know. They are equal, you can say. You cannot say its value until R value is given. Okay. So your answer here is 1.5 parallel with R plus R by 2. Thank you very much. You all. Bye bye.